Good afternoon, everyone. I am Ed Citzler, Sustainability Architect with the Corps of Engineers Headquarters. This is the Sustainability Webinar Series, and today we are going to learn about deep energy retrofits. We will answer questions at the end of the webinar. Today's presenter is Kirk Williams. Kirk Williams is Chief of the Mechanical Section for the Fort Worth District. Kirk has extensive experience in sustainable design and development, commissioning, lead, energy modeling, and LCCAs. He has served his career as the technical authority, subject matter expert, and designer on a wide variety of buildings for the DoD, as well as other federal agencies. He is a registered professional engineer in Texas, certified energy manager, and certified building commissioning professional. He was born, raised, and currently resides near Fort Worth, Texas, and he also won the USACE Gilvala Mechanical Engineer of the Year Award. And so, go ahead, Kirk Williams, and take it away.
Okay, thanks, Ed. So this week we're going to pick up deep energy retrofits. So welcome to the webinar series. I want to start by giving a shout out to Alex Douglas. He works in my section. He actually did all the heavy lifting on this presentation and helped get the content together, get the slides together. So I want to give him notice and give him a shout out for doing all the hard work for me. But it's a collaboration between him and I to talk on the deep energy retrofits portion. So I'd like to start out our presentations by pointing out the resources. So these slides will be uploaded to the sustainability SharePoint site. I don't know if Alex or Ed, if you could put that in the chat for people so that way they have it if you'd like to share it. So one of the primary things I like to do out of these webinars is get the resources in your hands. So the first one being the sustainability SharePoint site. So that's actually where this stuff is going to land. If you can screenshot that, or hopefully we can get that in the chat so you can copy and paste it. The second bullet is the executive order. We'll talk a little bit more about that further, but went ahead and gave that resource. And then the bottom three are resources that we've put together, or I guess we being USACE, ERDIC, and kind of that collective have put together covering the deep energy retrofit topic, I guess that's how I'll phrase it. So some really good resources in there. If you have a chance to look into that, it's a great resource. Dr. Ziev has put together a lot of stuff on that. He's a subject matter expert on it. He's just a general wealth of knowledge on this, as well as several other topics. He's out of ERDIC. So once again, want to give him credit and a shout out for the content that he put together. We used these deep energy retrofit guides to help kind of generate the content for these slides, and leaned on them pretty heavy. So really recommend those. The third bullet is more of a guide for decision making, so it gets more into the financials. And the fourth bullet is the technical guide, and that one is actually a really good just general document on sustainability if you ever get into that, especially if you're doing any kind of envelope design, because it gets into really good detail on insulation placement, thermal bridging, windows, and the like. They talk on several other things that we'll see here. They talk HVAC and lighting and things like that, but the window or the envelope discussion is really excellent out of that document. It's a big document, but there's a wealth of knowledge in there. So really recommend that. And then through this, we'll talk a couple of pilot projects that they highlighted in these technical documents as well. So we'll talk that, but there's a separate spot there for being able to reference to where there's more information on these pilot projects. So overview of our topic here our objective is to provide an overview of deep energy retrofit and implementation of kind of some examples from pilot projects. So the way we were going to discuss it was talking about the requirements, how USACE can support deep energy retrofits in major renovations, showcase a little bit of information about the pilot projects, and then quickly kind of discuss some best practices to keep in mind if you start going down that road. Just kind of a reference slide here for some common acronyms we're going to see here. Hopefully these are somewhat familiar to people. This is kind of just a kind of a you can circle back to if you're reviewing the slides later. We went ahead and used a lot of the abbreviations to cut down some of the text on the slides. But energy use intensity, this is your total energy use divided by your square footage. Gives you something to the effect of like your miles per gallon of your building. And then energy efficiency measure or energy conservation measure. So these are the actions that you're going to take to reduce energy. And then you have your life cycle cost analysis, which is economic evaluation. And then deep energy retrofit, which is obviously the content of this slide. So what is a deep energy retrofit? It's a commonly used term, but it doesn't actually have a globally established definition. So what we did here is we went ahead and pulled the definition down from the deep energy retrofit guide documentation that we showed on the resources slide. There is a little bit of a difference between some of the agencies' interpretations on deep energy retrofit, but it's a process of reducing the energy use intensity of the building, typically through a major renovation, the reducing the consumption by targeting 40 to 50%. I think GSA lists 40% on some of their stuff. We had 50% on ours. And that's the pre-building, or that's the building pre-renovation baseline versus the post renovation values. And then the added benefits are also you can achieve an improvement in indoor environmental quality and comfort, hopefully. So getting all those things together, and we'll talk about that as we kind of go further along here. But for a lot of people, they'll think of it as doing a major remodel with the emphasis on trying to target cutting the energy use by 50%. Or kind of sounds like a simple way to do things, but it can get a little complicated in execution. So requirements, like to bring that up. We have here the Executive Order 15057, catalyzing clean energy industries and jobs through that one. We have a couple bullets here highlighted. So this is a very high level overview of the executive order, and brought this up in the energy audits one. So this is the same content here, but we have the executive order stating that we're going to achieve net zero building emissions, and then give some dates there, and then also establishing targets to reduce energy and potable water use intensity. And so this is really kind of be the springboard that gets us into some of the implementation, and this is where this will directly tie into our content today. So these images here are from the executive order implementation guide, and we can see that through that they're targeting as some of the strategies implementing deep energy retrofit. So why are we having a deep energy retrofit webinar? It's going to directly tie back through the executive order. And I guess I should say, going back a slide here, the bottom in the red, DoD, Army, and USACE have sustainability plans that are based off of this executive order. We just kind of kept it at the high level here to kind of show where it came from, show that this is where we're getting some of the deep energy retrofit. And we talked about this in the energy audits, that the energy audits can work in parallel with your deep energy retrofits. So the energy auditing process is great for setting up your benchmark. So if our deep energy retrofit goal is to reduce 50% energy, then we need to have a baseline or starting point for knowing if we've achieved our reduction that we were targeting. And that's going to tie in with the existing facilities efficiency targets that they're setting down here through these that will reduce these EUIs, and then they have years and amounts that will be reduced. So you say support. So the executive order may bring requirements that or has requirements that may bring stakeholders to USACE for implementation. That either being, through contracting or performing energy audits and deep energy retrofits. So, um, you know, uh, already kind of brought up that the deep energy retrofits go hand in hand with energy audits. These things can kind of marry up with each other pretty well. The overall intent of, like I said, of this webinar is to kind of get the general knowledge of the concept out there, get people familiar with the terminology, since we have it in some of the hierarchy policy, and start getting people a little bit familiar with that. So when could a deep energy retrofit be performed? Obviously, when it's required by policy, that's a great time. When you're looking at planning a major renovation, it's a good way, and we'll get into that as far as thinking through your major renovations. You're seeking solutions for improved efficiency. So if you have customers coming and looking for ways to increase efficiency, if they have had issues or anything to that effect. So the last one is if you have facilities experiencing issues that are probably going to lead you towards the route of renovation. These could be telling signs that could lead you towards going down those roads. Building energy improvement. So building energy usage requirements from ASHRAE 90.1 have improved by more than 50% since 1980. So we continue to increase our minimum energy requirements, which is a good thing. That's driving us towards having more efficient buildings. Um, However, our facilities performance degrades over time. The impacts of the effects of the environment on the building envelope. The HVAC losing efficiency as the equipment ages. Leaks, things to that effect. And so we can lose, in the neighborhood of 10%, in energy performance, and to these things over the life of the building. And so these are the kind of things that, as we're looking toward the retrofit, and we're looking towards ways that we can do our energy improvements, some of the things that just in the renovation process we can be kind of cognizant and have in mind here. So whole building analysis. So hopefully the deep energy retrofit will look familiar to the folks that are familiar with our sustainability UFC. The application it marries up really well with how the UFC has us performing a whole building life cycle cost analysis. That's a lot of what goes into the deep energy retrofit. Is rather than doing a single retrofit of the HVAC system or a single retrofit of the lighting system, it's taking the whole building and looking at it with drawing the boundary lines bigger to the whole building to try to get improvements across several different systems, and then being able to use that kind of synergy of those relationships for optimization. So if you've improved your building envelope, maybe you can reduce your HVAC system. Maybe there's a means to enhance your lighting, your day lighting, which will reduce your lighting, and things of that effect. So taking a look rather than just we're going to write a statement of work or perform a remodel to fix just the lighting system. We take a look at what things we can bundle to make a good um, package that could possibly reduce the cost in some areas, or allow us to use some of the savings to offset um, capital investments into other categories. So shallow versus a deep energy retrofit. So shallow retrofit being focusing on a single measure. So that would be, just looking at your HVAC in the one area versus looking at the entire building. If we continue to look at shallow remodels, we will miss opportunities. If for example, the kind of the we had an envelope and rather than looking at improving the windows when we were going to do our HVAC replacement and seeing if we could, reduce the size of the units that we were replacing. If we could get new windows, at the same time that we were replacing the unit underneath the window that was sized, to handle the load from the window, we could have possibly seen some recovery. And you do that on a large scale, and that could trickle back to having a smaller chiller or things that could actually yield a tangible payback, as well as providing energy efficiency improvements. So a lot of it is drawing back your boundaries to your whole building. Like I said, that really lines up with a lot of the direction that we have as designers out of the UFC 1202, of looking at a whole building life cycle cost analysis when we're doing things. This is applying it to the renovation portion of things, if that can be within your renovation scope of work. So a lot of this would be communication with your stakeholders. My experience is when we've done sustainment, restoration, and maintenance projects, the stakeholder comes to us and they only want an HVAC remodel. They only want something like that. And so if you can have the conversations with them, if you can get them engaged to look at more of a building level, and especially if there's some synergy that could happen, and you have some of those possibilities. So cream skimming. So this is really coming in and taking the specific items that are going to yield your most cost effective, and just picking those off the top, and rather than looking at your whole building. So if replacing the HVAC with a more efficient system provides the quickest, highest return on investment, rather than just only doing that for a building, taking a look at the other energy conservation measures that may have a longer payback. So, a lot of times upgrading your active systems, your HVAC, your water heating, things of that nature that are active energy consumers. Those will have, if you're upgrading those with more energy efficient fixtures, they'll have a pretty short return on investment. A lot of times your passive features, your built-in envelope, your windows, things of that nature, they'll have a longer payback. So it's really trying to marry up your short payback items with your longer payback to get more of a medium kind of payback, if we can get to those kind of agreements with things. And so it's a little bit more long-term thinking, and kind of the investment in those, which we DoD as a whole tend to hold on to our facilities for quite some time. So the longevity, when we're doing our life cycle cost analysis, we're looking at things over a 40-year time span. That's a long duration. So that's giving a lot of time for payback. As far as that's concerned. So core technology bundles. So there's ways that you can bundle up these these individual elements that will yield what have shown to be kind of consistent blend of good results. There's a large number of individuals that can be applied to a building. That's, like I said, once again, getting into the resource guides is a great way to see just kind of the depth of some of the things that you can consider. Um, you know, Using this bundling method to really achieve what we could a greater result than we could individually. Um, you know, and then trying to optimize the cost to benefit ratio of implementing these energy efficiency measures. Kind of think of it almost as like trying to find the right recipe for making the perfect batch of cookies. Is you could have the individual ingredients, but if you can mix the ingredients and get the right mix for the perfect result, then that'd be great. Obviously, there's going to be the limitations with your costs, sometimes with your payback period, as far as when these things would break even. And so there's going to be some factors in there. So it would probably not be a one time. A lot of these is it's looking at a large number of these individual features, bundled together, looking at the different bundles, trying to figure out the one that would meet your stakeholders' needs while staying within your program amount, and trying to kind of find that perfect blend, or this the recipe to make the secret sauce. So what are some of these core bundles? So on your envelope side, you're looking at your insulation values, your wall roof slab, looking at your windows, your doors, thermal bridge remediation. Like I said, that the technical guide has really good discussion on thermal bridging, improving your air tightness, obviously your water vapor, and then also even just going back and doing quality assurance on some of these things. Your lower door testing, things of that nature. So getting assurance that we've done a good job with our passive. Looking at your lighting systems, trying to maximize your day lighting, maximizing control systems. Looking at your HVAC, getting into higher efficiency equipment. Maybe it's providing a dedicated outside air system, or doing something different with your outside air to provide better indoor air quality, possibly some efficiency gains by treating that air through a separate piece of equipment that's more efficient than a large traditional unit, or not even having control or something to that effect. Looking for ways to optimize with energy recovery, and then just kind of some general, what I'll say, kind of good construction practices of looking at is your ductwork insulated, is could we get more efficient by having our duct tighter, and then pipe insulation. And then obviously you can go down, and there can be a very long list. This is just a snapshot out of some of these, but bundling these things up. So if we knew that we needed a new roof, applying that. Also, while we were doing that, looking at, you know, what does our door and window situation look like? Would some of these be able to, possibly have us get better air tightness? Maybe we don't have control over the entire envelope, but working that in there, as well as taking a look at, they also wanted to implement LED lighting, and what can we do with the controls with that. And then some of this, and taking a look at if we did these passive features, what would the impacts be, and can we find a mix of those features that would possibly show us some equipment reductions on the HVAC side. So obviously, if you're going to do something that's whole building, the timing would work best if you were planning it with a major renovation. So, a lot of our stakeholders are good about knowing kind of when they want to plan for some buildings, having a major, remodel. It's, a lot of times it's, based on time. Sometimes it's based on, how the equipment and facility holding up. But the major renovation, so if you're going to be in there and you're going to be gutting the building already, you're going to have extensive, you're probably going to have the occupants out of there. You're going to be replacing features of the roof or the envelope, um, those kind of things. If you're already going to be in there for replacing mechanical, electrical, things of that nature. So really, if you're on a lot of these, we do see them taken down to the structure. And so you can kind of go back in, and go back in with an intentional plan, rather than we're only going to put a roof on, and then 2 years later we're going to deal with the windows, and then a year after that we'll fix this floor, this corner of the HVAC. If we can try to get them to marry that up into a comprehensive package for a major renovation, then we may see definitely some energy optimization, possibly some first cost optimization. So if you're developing a deep energy retrofit, you need information about the current building. Um, you know, any data you can get about the existing facility, as builts are always great. Just going into a remodel in general, but especially if you're going to be looking at a deep energy retrofit, if you can get any kind of actual usage data. If you can get any, maintenance cost, maintenance logs, those can help point to where some of the issues could be occurring. Um, if you can get any energy data, that would be great. Like I said, if we talked previously about the various levels of energy audits, and so possibly even just doing a preliminary, level one audit or something of the facility to get your baseline and possibly some low to no cost improvement items from right out the gate. Um, and then, through this deep energy process, you're likely going to be doing a building energy model. If you're running your LCCAs or your life cycle cost analysis, usually on something like this, you would be running an energy model behind the scenes to try to help with, projecting the estimated energy um, reduction. So yeah, so important information, building usage data, your life cycle cost baseline, your if you can get the operating building climate. A lot of times, our set point's supposed to be 78, but you go in there and it's set to 72. Some of these things will have impacts, if you're trying to predict, operation from first to from baseline to alternative. Obviously, any of the um, previous design documentation that's really great, especially if you're going to go into an energy model and try to model the envelope. It's really hard to look at the outside of a building and guess what the R value is of a wall. That's where the as builts and the design showing you that, oh, there's 6 inches of insulation back there. That's you know information that's really valuable. Same thing with the roof. I'd like to meet the architect that can stand on the outside of a building and tell me what the R value of a roof is from the ground. That'd be impressive. I bet Ed could. Your HVAC systems, seeing what those are, obviously getting the schedules to know what the scheduled equipment was, your efficiencies. That's if hopefully that'll match up with what's actually out there. Plug loads, that's going to be probably getting into the consumption data or any kind of meter data that you can get, or possibly just an estimation based on a site walk. And then your simulation calculation, that's probably what you will be run behind the scenes to help shape the decision making. So in the deep energy retrofit references, there were 7 pilot projects. There's a lot of information out there on deep energy retrofits. So you can just search it on the internet, and you'll come up with a lot of hits. GSA is doing a lot with it on several projects. So there's a lot of content out there if you want to see example projects. But the kind of common goals were they were looking to reduce their operating cost. They were setting performance standards. A lot of these were design build type contracts, so that they're writing into their contract a performance standard. They're looking to increase the value of the building. There's a lot of different ways to finance and things like that. So like I said, there's a whole documentation out of ERDIC on just the financing portion that can go along with that. And then obviously working to improve sustainability. A lot of these are seeing the resilience or self-sufficiency and energy security kind of added benefits of improving their passive features, and then just updating the older infrastructure. So 2 of the example projects we were going to just kind of quickly highlight, and some people might recognize some of these. The Presidio Army Barracks in Monterey, California. I believe that was a USACE job, and then there's another one, a federal building in St. Croix. So, if Ed needs me to go out there and do a site visit to either of these, I can volunteer for that. Um, so the technical aspects, you know, they use recommended um, recommended energy conservation measures bundles to get their deep energy retrofit to hit their their sustainability targets. So what bundles will actually get us to the metric that we define. If we define we're going to have a EUI of 25, the starting point is to look at what energy conservation measures can we do, what bundles can we create, what's going to get us closest to our target. And then using that to help shape the decision making. Obviously, there's going to be the balancing of looking at the financial aspects of what can we afford out of these bundles, and when we're packaging it up. Um, like I said, a lot of them use design build, and have the AE and contractor working together with that avenue with just setting their performance. And then a lot of them, they were able to see financial benefits as well as increased energy efficiency benefits through these pilot projects. So the first one is Presidio Army Barracks. So just right out of this, this has been presented several times through USACE. It was I remember sitting in mechanical communities of practice several years ago, and they were presenting on this. But the building was, overcrowded. They were going to change out the restroom facilities, get from gang use to personal. The residents were asked to do, things that were higher energy, but were doing operations like opening the windows because there was indoor air issues, odor and things of that nature, and a lot of the HVAC was non-functional. So it was a deep energy retrofit. They went in and improved the insulation. They used hydronic radiant heating. They used low flow fixtures. They're using LED lighting, Energy Star appliances. Improved energy and water metering. A lot of this is going to look like if you opened up the sustainability UFC, you would see a lot of these applications, from that sustainability UFC or from LEED. So a lot of this hopefully looks semi-familiar with that. So they were targeting an 80% site energy use reduction. They had 131 kBTU per square foot per year as their baseline, and they're hoping to go to 26. The results, as of when this document was posted, were showing 40 kBTU, which is what they actually were targeting, which was a 70% reduction. So didn't quite hit the target fully, but that was still a great one. If 50% is what we're going to use to define deep energy retrofit, then they well cleared that hurdle. Through that they talked about how the solar domestic hot water wasn't, kind of living up to everything that it was supposed to with that. And then they had some lessons learned, quality assurance process to ensure that you get your milestones, quality control, of the design and construction, especially your building infiltration. That's really vital if you're going to hit the metrics for your blower door testing and things like that. You got to be pretty on the ball consistently, and you can't just kind of hope for the best when you get to the end. Um, there were several things with it, and then they talked in there about being more prescriptive and less performance based in the RFP. So that can kind of go both ways for you. As some people have preferences on it should only be performance based, and others that should be very prescriptive. So um, that was some of their lessons learned out of the Presidio federal building at St. Croix. This one was retrofitted. Once again, trying to maximize the energy reduction. They were targeting trying to go towards net zero. That's great. We're going to start seeing some of that here. That's coming back around for implementation and conversations. So through the renovation, they installed PV panels, window film, HVAC controls. They were repairing the HVAC, and they were automation and addressing some of the electrical systems. So they were able to reduce their consumption by 36%, and then they were providing energy with the on-site PV panel. So obviously, if they were working towards net zero, they wanted to do the maximum they could to reduce, as well as the maximum they could to produce to try to get to that zero mark over the course of the year. So through that one, the outcome, which, like I said, there's the last bullet on the resources slide. There's a long, lengthy, you can get into the depth of it, but they were able to achieve net zero 10% of the time. And a lot of that fell on the PV panels, and they had a higher than expected building energy use, and so it'd be really hard to make up the power that you need to do net zero if you're not really conscious on conservation with some of those. So their lessons learned were that they weren't as affected by the fluctuations of the cost of electricity from the utility. Obviously the PV panels not maybe living up to what they thought as far as the power generation out of those. That if you're net zero, and you're creating electricity, you may not have a zero electricity bill. There are fixed fees and there are things like that. So there's going to be other charges that will factor into your utility structure, and that utility billing could be a whole webinar on of its own. Um, and then high level of collaboration. That's probably something I haven't harped on enough on this. Is through this, if you're going to do a deep energy retrofit, it's really vitally important that you're executing implement integrated design. You have the whole project delivery team there from the start. Everyone knows what the goals are. There's a level of communication, and especially if you're going to research and analyze a wide variety of individual energy efficiency measures to try to make them into group and bundles. It's going to cross multiple disciplines, so you need to kind of have everyone on there ready to work in a integrated design fashion. So rounding it out here with some best practices, um, you know, it's always a good one, if we're looking at doing a renovation to check to see if there's sources for problems. Is are we doing this renovation because the equipment's not operating, or what those functions are. Hopefully, if we can get in early enough in the planning, we can help kind of shape some of the scope of work for those, and possibly even get an energy audit in there so that we can define your baseline. Very much coordinating with your stakeholder to define your deep energy retrofit expectations. What's our target goal going to be? Um, you know, if you can get this to align, like we said, with your deep energy retrofit with a major renovation, hey, it looks like you're doing, the roof, the HVAC, and the lighting. This looks like it could, one or two more things, and we were in a major renovation here. What about if we looked at, the windows and the doors and the air tightness, and maybe growing a little bit would not actually be that much of a difference, and you could work with your stakeholder and show them, several small projects could end up costing more than one well-planned major renovation. Anytime you can get meter data, that's like we showed in the picture, that's a gold mine. So getting meter data, if you have it, to baseline your existing conditions. Yeah, I mean, anytime we're doing that, trying to define our reporting documentation expectations, especially if we're working with a design build, and we're someone else is going to be doing the design off of a performance base, is making it really clear, what the expectations are through that. Coordinating your quality control or quality assurance reviews, of the progress, that being, in design as well as in construction, keeping thorough oversight, getting to the end and trying to measure the outcome if we haven't been, you know, keeping up and doing our quality assurance, like I said on the blower door test. The day of the test is not the day to worry about if we've done it correctly. It's a consistent, daily practice of sealing holes, making sure that we're being cognizant, because getting to the very end and hoping for the best on the test will probably not be successful. Integrated design, so getting all the disciplines in the room. As a mechanical designer, y'all listening to your mechanical designers, um, performing detailed energy modeling. So energy modeling heavy to try to get what each of the energy efficiency measures would probably do. If there's any inherited gains, of, hey, we do this level of roof insulation and we drop this amount of HVAC load. So those kind of optimizations, um, analyzing multiple combinations, that kind of goes hand in hand with it. You'll also be, probably costing multiple combinations to then try to run scenarios where you have your life cycle cost analysis. And then obviously going and researching other lessons learned, looking at your pilot projects and looking at any other previous projects, and just trying to, inherit wisdom from the others that have gone before you. So I think with that, we're at the end here. So um, I'll I'll I guess drop it off the recording, Ed, and I'll go ahead and stop sharing here, and we can talk through if there's any questions in the chat.
Absolutely. Thank you so much for the presentation. That was very informative. So right now, put your questions in the chat and we'll answer them in the order that they're placed there.